Next, I want to look at the graphs of cosecant and secant. And actually, the graphs of cosecant and secant are really built around the sine and cosine curves. And you want to remember that, cosecant is the same thing as 1 over sine, and secant is the same thing as 1 over cosine. So there is a relationship there between them already that we've seen, of course, right? So here you have first the graph of cosecant. Oops, I forgot one of the C's. And what you can see, I just drew it in lightly in purple, is the graph of sine x. And actually what happens is the graph of cosecant sort of bumps off the graph of sine at that upper and lower points there. And there's lots of vertical asymptotes here. So for cosecant, for the base cosecant function, your vertical asymptotes occur at 0, pi, 2 pi, negative 2 pi, etc. Every pi interval, you have that vertical asymptote. Other things I want you to notice is that you have above your lowest point there is starting at 1, really at the top of the sine curve. And below, those U-shapes are starting at -1 and going down. So you're at the bottom of that sine curve. And your period is 2 pi here. So I am showing you 2 periods. For secant, remember that is 1 over cosine. So again, it does something very similar. It bumps off that cosine curve. So in light purple, I just kind of drew that cosine curve so you could see. And it looks very similar to cosecant. And it's really just a shift over. And what happens here again is those U's above occur at the top of the curves so that they're starting at 1 and going up. And then on the bottom, again, they're starting at -1 on the y-axis and going down. They're kind of bumping off the cosine curve here. And in this case, you still have period 2 pi, but your asymptotes instead are at negative pi over 2, positive pi over 2, 3 pi over 2, and so on. So still going by period 2 pi there, but they're kind of going on the fraction pi's instead, on those half pi's. But again, they both have period 2 pi. So those are your base ones. And I do highly recommend you graph them in Desmos as well, just so you can see a nice clear picture or look at your text or online. I did my best here to draw, but they may be a little messy. So hopefully you get an idea of what they look like overall. Okay, now we're going to talk about variations of cosecant and secant curves. And what we actually do there, one of the easiest things you can do is to actually use the sine and cosine curves. Because if you remember from the last page, you were able to kind of see how those two curves related, the cosecant and the sine and the secant and the cosine. So what you want to notice are a few key things. That your x-intercepts on your sine or cosine curves would be the vertical asymptotes on the cosecant or secant curves. The other thing you want to note is that the max and min points on your sine and cosine curves are where those U-shapes start on the cosecant and secant curves. So for instance, just kind of going back for a second, right? So wherever you have an x-intercept on the sine curve, you would have a vertical asymptote. And then those max and mins tell you where those U-shapes kind of start. Here going above and here going below. So we already know how to graph sine and cosine pretty well. So if we can graph that first, then we can use that to build the cosecant or the secant graph from. So what we're going to do here is we're going to use the graph of 2 sine 2x to graph y equals 2 cosecant 2x. And you can see how they're related. Everything's the same except for the trig function has changed. We've done lots of sine stuff before, so to save a little time, I got us started. So again, I'm working on the sine curve here. The value out front is my amplitude. So that's going to be 2 here. So I'm going to be having that little bit of stretch vertically. And then my period is typically 2 pi, but because I have an inside multiplier, we divide it out. So my period here ends up only being pi instead. So it's oscillating a bit quicker. There is no phase shift here. There's no vertical shift, so I don't have to worry about that. So for my 5 key points, I'm still going to be starting at x equals 0 for the sine curve. And then remember to find the next point, we add the period divided by 4. So period divided by 4 is pi over 4 here. So 0 plus pi over 4 is just pi over 4. And then adding it along, I got my next point is pi over 2, 3 pi over 4, and pi. What I did next is I set up a little table and I plugged those values into my sine curve. So I went through the full process for graphing that. So I started with 0. So I took my 5 key points. Sine of 2 times 0 is just sine of 0. Sine of 0 is 0, so 2 times 0 is 0. Here, 2 times pi over 4 is pi over 2, and sine of pi over 2 is 1. So 2 times 1 is 2, and so on. I went through and I found those 5 key points, and I graphed my sine curve. Now this does keep extending. So I only graphed one period here, but of course, this pattern does continue on. So you can kind of, just get that idea there. And again, I did it in light purple because I don't really care so much about the sine graph. I really want the cosecant graph. So I'm going to remember a few things. So first thing, remember that your x-intercepts on the sine curve are going to be vertical asymptotes. So I'm going to go again and just use pink there to help me. So I'm going to have a vertical asymptote here. I'll have another one here and another one here. Now remember, vertical asymptotes are not actually on the graph. I'm just drawing them so I can visualize what's happening. So I'm trying to use a light color just so you can just lightly see that. You could use a very light pencil. And again, they're not actually part of the graph. Actually, nothing here is part of the graph that we're looking for. It's just to kind of help us draw the rest in. And then what happens is our max and min points on, in this case, the sine curve, are going to tell us where our U-shapes start. So here, because of that amplitude is 2, we're actually starting up at 2 instead of 1. And I'm going to do our graph for the cosecant in blue here. So you would have a U shape like this. And then here you would have a U shape like this. And again, you'd have another one coming in this way, and another one kind of coming in this way, and so on. So you would just kind of bump off that sine curve here, heading either up or down. So that amplitude of the sine curve does actually affect where those U's start. And remember, those x-intercepts are going to be where your vertical asymptotes are going to be. So this is how we can graph cosecant, or how we can graph secant as well. All right, maybe we'll just do one more example there. All right, so let's do another one. Let's fix that for you guys. So here we're going to graph again another example. This time we'll do a secant. So it's going to be related to cosine. We're going to graph it over the interval negative pi to 5 pi. So I may need to extend my graph a little bit more. But let's get started. So remember, what we're going to do instead, we're going to look at, now here secant is related to cosine, right? It's 1 over cosine. So I'm going to use the cosine curve instead. So I'll use this curve instead. Excuse me. My amplitude here is the absolute value of -3, which is 3. Now I don't have a vertical shift, so that 3 and -3 will be my max and min values. I do notice it's a negative though, so what's going to happen is you are going to have a flipping. It's going to look opposite than what it normally does. My period is being affected. It's 2 pi over b. Here my b is 1/2. So multiply by 2 over 1. And you actually get 4 pi for the period. So it's oscillating a little bit slower. Instead of being over 2 pi, it's over 4 pi instead. So we do have this change. I'm going to go ahead and find my 5 key points. I don't have a phase shift, so my first point will be at 0. Remember, there'd be a phase shift. There's like a plus or minus on the inside here. I don't have that here, so I'm not going to worry about the phase shift. And then for my second point, I'm going to take that 0 and I'm going to add whatever the period is over 4. Now, the period over 4 is going to just be pi. So my next value will be pi, and I'm going to add pi each time. So I'd have 2 pi, 3 pi, and I think you can see the pattern now. The last one will be 4 pi. And again, I'm really spending my time here graphing cosine, not so much our function that we care about. It's kind of funny, right? Doing something else first. So I'm going to plug this in. -3 cosine of 0 over 2 would be -3 times the cosine of 0. And our cosine of 0 is 1. So -3 times 1 is -3. And again, I'm going to continue with the other values as well. So you can go ahead and plug the other values in, and what you're going to get for the next one is 0, and then 3, and then 0, and then negative. All right, so I'm starting at 0. I'm going to go by pi's here. So pi, 2 pi, 3 pi, 4 pi. I'm going to go to 5 pi because it does ask me to go to 5 pi in the directions, even though I'm ending at 4 pi here. 0, and then I'm going to go down one more to -pi for the directions. So I'm going to graph this in purple, because again, this isn't really the graph that we need, right? So at 0, I'm at -3, 1, 2, 3. Okay, so -3. At pi, I'm at 0. At 2 pi, I'm at +3. At 3 pi, I'm at 0. And then at 4 pi, I'm at -3. And the pattern will continue. So even though I don't have all the values here, if you think about it, right, notice that after we were low, the next pi, we went up to 0. So again, this one would go up here and can continue on. And then same thing this way, you could just kind of follow that same pattern. And I'll stop there, but it will continue on as well. So this is our cosine curve. Now our vertical asymptotes are going to occur at the x-intercepts here. So I'm just going to kind of lightly draw those in. It's just really, again, a guiding for me. It's actually not part of the graph. And then my actual curve, I'll do in blue. And that's this one right here. This is what we're actually trying to graph. And remember, what I'm going to do is I'm going to bounce off those max and mins. So I should have drawn this a little bit, maybe higher, but this is going to be my u going up. Here I'll have a u going down. Here I'll have another u and kind of going up. Here I'll have a u down. And again, here I'll have another u kind of going up, running out of room there, but that would continue on. So the blue one is really what we're looking for here. But instead of trying to learn how to graph something new, we use the tools we already know, because we're hopefully at this point, we're pretty good at graphing sine and cosine. We spend a lot of time on that. So we can use that to graph the rest of our functions here instead. Now, just a little side note too, in your book, before I end this video, you do have a nice, and you can get these online too if you don't want to print it from the text or anything, but you do have just a nice summary of what those graphs look like. So if you don't have this, you may just want to put it in your own notebook and draw it by hand. We've done them all. Or you can just search online and Google for the graphs, and it's just nice to have that quick reference. Particularly for sine and cosine. I know sometimes I always mix up which one starts at 0, which one starts at 1. Just little things like that, so you don't want to make a mistake, and just kind of have that kind of part of the initial graph, and that will help you. Same thing with tangent and cotangent, right? Because they look very similar. So if you just make yourself a little note card, a little cheat sheet, it may help you just to have those general shapes, and then that will jog your memory as you're going through.